Good evening, I'm Mark Stewart. If you have only arrived at USF within the last 15 or 20 years, you may not know who I am. But I've been here now for 36 years, and don't believe Raines when he says that the only reason I've been here that long is I can't remember how to get home. But also 36 years here proves that not all the fossils are in the Morrison Museum. I'm still teaching the usual stuff. I teach large lectures in oceanography and now global climate change, which is going pretty well. And I still am torturing students in advanced hydro with the impossible workload. And my carbon sequestration group is moving along. We had 2 more papers appear this year. I wish you all well. I'm around here for a few minutes every week, and if you're in a department, stop by and say hello.
I'm Judy McElrath, and I'm standing on glacial moraine at the western margin of the Greenland ice sheet, about 60 kilometers east of the town of Ilulissat. Behind me is Jakobshavn Glacier, the fastest moving glacier in the world.
Welcome to Ilulissat. These are the icebergs that calve off Jakobshavn Glacier and float 60 kilometers down the ice fjord and eventually end up here. It's also where we'll prepare equipment and supplies to be dropped off for 2 weeks in this barren landscape. Well, almost barren. The radar will run 24 hours a day, and while we're here, we'll see calving events like this one.
Hi, I'm Sarah Cruza. I teach geophysics and parts of the structural geology class. I've been working recently in wetlands with graduate student Christine McNiff, and in the geopark on sinkhole formation and hydraulic function with Henrik Kiflu. And Leah Cortland is almost finishing her thesis looking at cinder cone formation, where we've been using ground penetrating radar. Some of the most exciting work I've been doing in the last few years is I've been doing workshops on near-surface geophysics in different parts of Central and South America. It's always very satisfying. After 2 sabbaticals in Central America, I've gotten to the point where I could give workshops in Spanish, and they're always very formal, these workshops. Here's an example. I'm an official guest of the city of Sucre, Bolivia now, as a result of participating in this workshop.
Hi, I'm Rocco Masservisi. I'm an assistant professor of lithospheric dynamics and geodesy here at USF. I'm mainly involved in studying how we can relate the surface deformations that we can measure, for example, from GPS, to processes that can cause this deformation.
Hello everyone, I'm Bogdan Onak, Associate Professor at the Department of Geology. Right now I'm spending my sabbatical leave in Mallorca, Spain, and I am on one of the cave sites. I'm working with one of my PhD, Lee Boop, and we just finished collecting or downloading the data from a number of probes measuring temperature, conductivity, pH, salinity, water level, and so forth. My field of expertise are karst geology. I'm doing a lot of mineralogy in caves mainly, and also paleoclimate studies based on cave deposit.
Hi, I'm Zach Atlas. I'm in charge of our plasma facilities. We have here our inductively coupled plasma mass spectrometer, and back behind me we have a direct current plasma mass spectrometer. So we've had quite a number of different research projects run through this particular lab. We also get quite a number of external research coming through here through the Department of Chemistry, Department of Physics, biology. We've had folks from Moffitt Cancer Research come to the lab. We've looked at all sorts of new materials, as well as actual cellular materials that people are trying to understand to give them a better idea of trying to find cures for cancer and other diseases.
Good afternoon or good morning. My name is Steve McNutt. I'm a professor in the geology department here. My background is in volcanology and seismology. Also work on infrasound and volcanic lightning. So I'm a new professor here. I got here in August of 2012. I'm still setting up a seismology lab and preparing to teach some classes in seismology. What we'd like to do is set up a laboratory with data coming in from volcanoes in Central America, and have seismometers which measure mechanical vibrations of the ground, that's earthquakes, deformation, so that's slow moving deformation of the ground rises or falls, for example, if magma is put in the crust. Infrasound is low frequency sound, so when a volcano erupts, not only does the ground shake, which is the earthquakes, but it produces sound waves in the atmosphere that have low frequencies, so they're below the threshold of human hearing, but you can record them on infrasound sensors. And then the final thing is volcanic lightning. There's electrical processes that occur in the erupting volcanic ash cloud, and we'll set up sensors to record the lightning and electrical activity there.
My name is Jonathan Nguyen. I'm a biogeochemist who uses stable isotopes to trace low-temperature geochemical processes. I've got a couple of active research projects right now that I'm very excited about. I'm working with a group of paleoanthropologists on using stable isotopes to understand the diets of earliest humans. So one of the questions we had based on some previous work was whether humans were consuming meat and how early they were consuming meat. And we had found some cut-marked bones that indicated that Australopithecus afarensis was consuming meat at about 3.4 million years. The other project I've been working on the processes that are driving ocean acidification. My role in this is really sort of using the stable isotopes to trace sources of additional fresh water. The Arctic is actually relatively dilute near the surface because of terrestrial runoff, but also because of sea ice melt. And we can use stable isotopes to say how much of this additional fresh water comes from the melted sea ice that we've been observing over the last several decades.
Hello, I'm Matt Pazik. I'm an assistant professor here in the geology department here at USF. I am a professor of geochemistry. My research focuses on phosphorus geochemistry as well as a little bit of lightning geochemistry. Pardon me, these are things known as fulgurites, and a fulgurite is a lightning strike glass. This one here is from Denver. We have a few others that are from Florida, so you can see a little bit of a size and shape difference. These are some of Florida's only igneous and metamorphic rocks that we have in this state, and so they're interesting from that perspective alone. Some of our new research has been on the oldest rocks on the surface of the Earth. And what I have here is a sample of carbonate, the oldest limestone known on the Earth. It's about 3.5 billion years old. And we've been doing some analyses on this limestone, one of the most rare limestones you'll ever find too. Some of the phosphorus within this stuff actually came from meteorites. And there's some very large implications for understanding both the history of phosphorus on the Earth, early Earth, and at the time of origin of life, in addition to having implications for understanding how life developed on the Earth as well.
My name is Mark Rains. Some of you may remember me from my role as guy on Skibatical in last year's video. And I'm unfortunately unable to reprise that role this year. Instead, I'll tell you a little bit about some of the work we're doing right now. I'm currently in the Sacramento Valley of Northern California. And this feature you see behind me, this little hole in the ground with water in it, is a vernal pool, and there's literally hundreds of thousands of these in headwater settings all throughout the Sacramento, San Joaquin, and Bay Delta regions. Well, it looks rather small and kind of insignificant, and in and of itself it probably is, but because there's so many of these and they are located throughout these headwater settings, we hypothesize that they do in fact play an important role in terms of maintaining the physical, chemical, and biological integrity of downstream waters. And the way they do so is that water perches here, rises up to the surface, expresses at the surface here in these depressional features, eventually spills out, and for many months spills out, in this case off to this direction through a swale system into an unnamed, unmapped stream, down into a named and mapped stream, and ultimately out to the Sacramento River. And at that junction between this stream and the Sacramento River is critical habitat for Chinook salmon and steelhead, both of which are federally listed endangered species. And so we hypothesize that the water that comes out of here and the quality of the water that comes out of here play important roles in maintaining that critical habitat at that junction environment.
Hi, I'm Paul Wetmore. I'm the structural geologist in the department, teach the undergrad structural geology course as well as graduate courses on anything from magma ascent and placement to active tectonics. I have 4 graduate students, Brian Ferwerda, James Wilson, Nate Nushart, and Cosmin Strumton. 3 of them, all except for Nate, should be graduating in 3, 2, hopefully. But we've got a group that's working on also a variety of projects and everything from magma processes to active tectonics in Mexico. And that's about it.